Question: what is the heat that must be added to 50 kg of ice at 0 degrees Celsius? What is the heat that must be added to 50 kg of ice, 50 kg of ice at 0 degrees Celsius, to convert all of it to steam at 100 degrees Celsius? So we are going from ice at 0 to steam at 100 degrees Celsius. Latent heat of fusion of ice is given 335 times 10 to the power of 3 joules per kg. Specific heat capacity of water is given 4,186 joules per kg per degree Celsius. Latent heat of vaporization is given 2,260 times 10 to the power of 3 joules per kg. Welcome, enjoy. So we have to go from ice at 0 to steam at 100. So we have 50 kg of ice at 0. That ice at 0 is going to absorb heat until it becomes water at 0. Once we have water at 0, and as you absorb more heat, what happens? Your temperature is going to rise. So we have to go from water at 0 to water at 100 degrees Celsius. And we are absorbing even more heat. So now what happens? From water at 100 degrees Celsius, it becomes steam at 100 degrees Celsius. There is a phase change from ice at 0 to water at 0. There is a phase change. So we use latent heat of fusion of ice. We are going from solid to liquid. We use latent heat of fusion. Latent heat of fusion of ice is the amount of heat that you need to convert 1 kg of ice at 0 to water at 0. So for mkg, it is m times Lf. So now we have water at 0, and then what do? From water at 0, we go to water at 100. There's a change of temperature involved. What is specific heat? Specific heat is the heat required by 1 kg of substance to increase its temperature by 1 degree Celsius. For 1 kg and 1 degree, it is C. So for mkg and for delta T, it will be mc delta T. Once we have water at 100, we have to convert water at 100 to steam at 100. There is a phase change. Because we are going from liquid to gas, we use latent heat of vaporization. All these quantities are given. We know mass, we know latent heat of fusion. We know mass, we know specific heat, we know delta T is 100. We know mass, we know latent heat of vaporization. So substitute all those numbers that we know. Mass is 50 kg. Mass is 50 kg. And what is latent heat of fusion of ice? 335 times 10 to the power of 3 joules per kg. So kg and kg cancels out, so you get your answer in joules. From water at 0, we have to go to water at 100. For that, we use mc delta T. Same phase, but increase in temperature. We know the mass, we know specific heat, we know delta T, cancel kg, cancel degrees Celsius. What do we get? In joules. And once we have water at 100, now what do? We absorb more heat, and now we convert from water at 100 to steam at 100. You're going from liquid to gas, so you use latent heat of vaporization. So you go with 50 times 2,260 times 10 to the power of 3. Again, kg and kg cancels out. So you get your answer in joules. Do all the multiplication and we get these numbers. You just add. And what do we get? 150.68 times 10 to the power of 6 joules. The heat in joules that must be added to 50 kg of ice to make it go from ice at 0 degrees Celsius to steam at 100 degrees Celsius. This is the amount of heat that you have to add. The answer is in joules. This is George Mathew signing off. Good luck.